Good morning. In this video, we are going to continue with chapter 10, circles. In the previous video, we have seen what is a secant and what is a tangent, and also a theorem on tangent. Now, we are going to move on to the next subtopic, number of tangents from a point on a circle. In 9th standard, we have already studied that a circle divides a plane into three parts: interior of a circle, the circle, and exterior of the circle. Isn't it? So now let's see a circle and a point on the interior of the circle. How many tangents can we draw from this point to the circle? Nothing. Because if you are going to draw any line, it won't be a tangent. It will pass through the circle. It's definitely not going to be a tangent for us. So from a point on inside of a circle, the number of tangents that we can draw will be 0. The next, if a point lies on the circle, then we know that only one tangent can be drawn through it. We already studied that. Now, the third case, suppose if a point lies outside, that is on the exterior of the circle, how many tangents can we draw from here? 1 and 2. So, 2 tangents can be drawn when from an exterior point to a circle. So, we will have 2 points of contact. Let's take this to be P. This will be P1 and this will be P2. T1 is a tangent. T2 is also a tangent. Here also T1 and T2 are called as point of contact. The distance of T1P as well as T2P is called as the length of tangent. Now, we will see a theorem on length of tangent. Theorem 10.2. The statement is, the lengths of the tangents from an external point to a circle are equal. So, we are going to have tangents from an external point to a circle. I told you that is called as the length of the tangent. They are equal. That's what the theorem statement is. So, first of all, we are going to take a circle and then external point. We are going to join the tangents from this point to the circle. Circle will have center, let's say O. This is P with the point of contact. Let's take to be Q and R. Okay. So what is given for us? Given that P is an external point to a circle with center O. Okay, and PQ, PR are tangents, 2 tangents from P. From the point P, we are having 2 tangents. This much is given to us. Now, what do we have to prove? The lengths of the tangents are equal. That means, what are the lengths of the tangents? PQ and PR. PQ equal to PR. This is what we have to prove here. Now, proof. For proving this, let us first join OP, OQ and OR. Okay. So, join OP, OQ, OR. Okay. Now, from the first theorem, we know that radius and tangent are perpendicular to each other at the point of contact. So, this angle is 90 degree as well as this angle is 90 degree. We have to prove PQ equal to PR. So, we will take these 2 triangles and we will prove them to be congruent. Okay. Then by CPCT we can prove that PQ equal to PR. So, PRO equal to 90 degree. Why is that so? From theorem 1. Don't write theorem 1 here. You have to write the complete statement. Okay, so what is it? Radius is perpendicular to the tangent at point of contact. So both the angles are 90 degree, and OP is equal to OP. That is a common side for us. OQ is equal to OR because they both are radius, or in plural radii. So therefore triangle PQO is congruent to triangle PRO by RHS congruence condition. What is that? Right angle hypotenuse side. Okay. Now from this we will get that PQ is equal to PR by CPCQ. What is CPCQ? Corresponding parts of congruent triangles. Hence, we have proved that the length of the tangents are equal. So, if you are going to have an external point to the circle, we can draw two tangents from the point to the circle, as well as the length of the tangents are going to be equal. Okay, this is another important theorem. In this chapter, we are having only two theorems. Both are important, and we will be solving a lot more questions in the exercise based on these. Now we will start with exercise 10.2, which is at the page number 214 in your NCERT textbook. Okay, we will start with question number 4. Question is, prove that the tangents drawn at the ends of a diameter of a circle are parallel. So, first let's draw the diagram. We are having a circle and we are having a diameter, center, and then we are having a diameter. Okay, prove that tangents drawn at the ends. These two are the ends of this diameter. Over here, we are going to draw tangents for it. So in here, there's a tangent, as well as over here. Okay, we have to prove that these two are parallel. Okay, so this is our diagram. Let's name it. The tangent to be AB and CD. Let it go. Point of contact between Q. Okay. So given AB and CD are tangents to the circle with center O at points P and Q respectively. Okay. What do we have to prove? That these two lines are parallel. That is, AB is parallel to CD. That is what we have to prove. Okay. So prove that is, now PQ is the diameter, so OQ is the radius for it. Okay, we know that radius and tangent are perpendicular to each other at the point of contact. Same goes over here also. So this is 90 degree, this is 90 degree, this is 90 degree, as well as this is 90 degree. So we will write that much first. Since radius is perpendicular to the tangent through point of contact, OQ is perpendicular to C and OP is perpendicular to AP. We can write them together. A perpendicular means angle OQC is 90 degree. Angle OQD is also 90 degree. Angle APO is 90 degree. Angle BPO is also 90 degree. Now, I am just writing numbers for your reference. Now, let's take this to be 1, 2, 3, 4. 1 is equal to 2 and 3 is equal to 4. All are 90 degrees. So, we can consider it that way. That means what? Alternate angles are equal. So, therefore, these two lines must be parallel. We don't have these numbers. We are just going to make them. Okay. So, that is angle APO. This angle is equal to angle OQD and angle BPO is equal to angle OQC. Alternate angles are equal. Therefore, AB is parallel to C. Hence, we have proved it. Okay. So, this is very easy. We are just using the first theorem and then arranging them in such a way that alternate angles are equal. Then we prove the lines are equal, parallel, or the tangents are parallel to each other. Okay. Now, we will solve question number 5. Question is, prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So, we are having a circle and a tangent. Through the point of contact, we are going to draw a perpendicular line. We have to prove that that line passes through the center. Let's draw the figure for it. So, we are having a circle. We are having a tangent also for it. That's the center. Point of contact B. So, it may be XY. Okay. So, from here we are having a perpendicular line. We have to prove that that line will pass through the center. Now, let us assume that there is another point Q. Okay. And that perpendicular line which we are talking about actually passes through Q. Okay. We will join OP also. We will assume it to be this way. XY is the tangent to the circle with center O and P is the point of contact for us. What do you have to prove? Perpendicular through P passes through the center, which is the center for us O. So that's what we have to prove. So for proof, let us assume that the perpendicular passes through Q. So assume that the perpendicular passes through Q. Okay, so that means OP is perpendicular to XY, isn't it? That means this angle is 90 degree. So that is QP is perpendicular to XY or angle QPY is 90 degree. This will be our first equation. Okay. Now O is the center. So OP is the radius. Now again from theorem 1, we know that OP is perpendicular to XY at the point P. Okay. So now OP is also perpendicular to XY because radius is perpendicular to the tangent at the point of contact. Okay. So that means angle OPY is also 90 degree. Let's take that to the equation number 2. That means both the angles are equal. So therefore angle QPY is equal to angle OPY. But if you see in the diagram, O is perpendicular, but Q is slightly towards here. So the angle is definitely not 90 degree. Maybe it is 85, 80, whatsoever, it is definitely not 90 degree. It is clear from the figure. It is clear from the figure that angle QPY is smaller than angle OP. So it is clear from the figure that angle QPY is less than angle OPY, isn't it? It is clear from the figure. So that means what? Angle QPY is definitely not equal to angle OPY. So first we are saying that the angles are equal, and then we are telling that the angles are not equal. Okay, this is called as method of contradiction. That is, first we assume something and then we are proving, and then we come to a point where the statement is contradicting each other. First we are saying equal, then we are saying not equal, isn't it? This is called as proving by method of contradiction in mathematics. So when we arrive at that point, it means that our assumption is wrong. Now what was our assumption? Assume that it passes through the point Q and not O. That assumption is wrong for us. So that means Q and O are the same. So they will be equal. That is what we have proved, isn't it? They will be equal only if OP and QP coincide. Coincide means they are the same. So OP and QP are the same. That means what? It passes through O. It passes through the center. So hence perpendicular through P passes through the center. That's all we have proved. Okay, so this is method of contradiction. I'll repeat again. You all know given and to prove. In proof, first we are going to assume that O and Q are different. Okay, so QP only is perpendicular. That is what we are assuming. Okay, so angle QPY is 90 degree. Now we know that radius and tangent are perpendicular to each other. So OP is perpendicular to XY and this angle is 90 degree. But by looking at the figure itself, you know that QPY is smaller than OPY. So that means they both are not equal. First we are saying they are equal, then we are saying they are not equal. That means there is a contradiction over there. So for them to be equal, it is possible only if they are coinciding. Okay, so we prove the question. Clear? Thank you. So for today, we are having only this much. Question number 1, 2 and 3 of this exercise are homework, as well as example 1, 2 and 3. Try to solve it yourself. They are not hard. Anyway, you are having only 2 theorems. You will have to apply them appropriately in order to get the answer. Okay. Thank you.